And I'm presenting here basically some bases of replication and some mixes that you can do with other replication setups, basically, and some migrations that you need or you want to do, how to do them. So mix and match, asynchronous and group replication for advanced replication setups. So yeah, you can trust me. You can trust me, right? And honestly, I'm talking about migrations and stuff, but I'm not a DBA, I'm a developer, so sorry if I make some mistake. Or support people, don't kill me, please. So basically, I'll start with some background on replication, and then some mixed setups, and how to do some migrations. And starting from the very basic. In the beginning, there was asynchronous replication, so everyone knows this, right? You have a master, you write to the master generates events that go to the bin log, these events go to slaves. Slaves are asynchronous, and ideally you want slaves to back up your data or to scale your reads. So writes go to the master, reads go to the slaves, and you can read stale data on the slaves. So that's it. And then on 5.5, it was introduced synchronous replication. So basically, it's the same setup. You write to the master, you read from the slaves. The difference is that when you write to the master, you can wait for the slaves to acknowledgement. So ideally, the master will only commit if some of the slaves or all the slaves, you can configure it, acknowledge that they queued some data or they committed or they are committing the data. So you still have master slave, but now when you commit on the master, you know that the data will be on the slave. It's a cost that you can choose to have on writes, so your reads will be more synchronous. And also on early 5.7 GA, we added multi-source replication. So multi-source replication added to the slave the notion of channel, and the channel is basically a connection to a master, and a slave can have several channels. So a slave can receive information from several masters. There is no conflict resolution. If you use this, we assume you know what you are doing, right? So basically you can use this for aggregation or backupping several masters at the same time, stuff like that. And again, writes goes to the master, reads goes to the slaves, so business as usual. And finally, we now release SGA group replication. So on group replication, you have notion of multi-master, even you have configured it as a single master with secondary masters. But basically, there is a group where every transaction that you send to the group is totally ordered and received in every server at the same time, at the same logical time. So you can choose to write to several members at the same time. And basically, this is a distributed state machine, right? So everyone starts with the same state, everyone receives the same information, so everyone does the same decisions. So we use that, like Peter was talking about certification. Certification uses that information to know what is concurrent and what is not. So ideally you have conflict resolution on multi-master. Or you can choose it to have on primary master. And the same slide that Alfredo presented. Group replication everywhere with automatic distributed recovery, conflict detection, and group membership with automatic failover and fault tolerance, and you can write everywhere. And if your primary dies, the group automatically will choose a new primary, so you don't have to be concerned with that. And it's a node suddenly dies, it is kicked out of the group, so you don't have to worry about that as well. So this is group replication, and we release it, and you look at, okay, but can I mix it with the other replication solutions? Of course. So basic scenarios. So group replication is limited to 9 members, but maybe you want to scale out to like looking to 100 slaves. You can still do it. You can have a group with several masters. Either it is multi-master or single master, it doesn't matter. You can still replicate from the group and have asynchronous slaves, so you can scale out reads or do backups on chip hardware, wherever you want. So you can read from these slaves. And the group will have automatic failover, right? If one of those guys dies, the group will adjust and pick a new primary if you have that configured. Slaves, not so much. So if you are replicating from one of those masters and your master dies, then you have to reconfigure the slave to connect to another master. At least now, let's see what the feature brings also on this field. Then you can also do some stuff like data aggregation from different groups. No one stops you from having a multi-source replication from different groups. So you basically have an external slave that will be configured to have 2 channels and replicate from 2 groups. And again, you can use these for data aggregation, to do some backup on chip hardware, stuff like that. More advanced setups include this, that is a common use case that we see. And you have multiple data centers or regions, and basically you have active groups on each data center, but you still want to replicate from one group to the other. As Vitor said, it's not optimized yet, but you can have a group that spans multi-data centers, but we don't advise it because it's not optimized yet. But you can still replicate from one data center to the other in a circular manner. So you just connect one master from one data center to another and vice versa. You can use one pair of masters. I use 2 pairs here because if one of the master dies, then only one of the directions of replication is dead, the other is still working. And it's still a synchronous replication, but if you have different workloads or different users in different data centers, maybe you don't care that much in that delay. Yeah, maybe you can still control it somehow. And for scenarios, maybe you have another scenarios that you can speak to me or to the team and ask us if we ever thought of them or if we advise them or are against them. And now about migrations. So the simplest case, right? I have a master slave set up. How do I go to multi-master if I want to? So here what I did is that I have a multi-master, I have a master slave set up with rights to the master, reads to the slave, and I choose to add a new member that is a slave to M1, and I start a group on it. I could also do this picking up a slave and starting group replication on a slave. It will be identical. But maybe you don't want that because to not disrupt the current setup. So you can have a new member, start group replication on it, start replicating, and when M2 catch up to M1, you can start migrating other slaves to the group. And in a sense, the group is also a slave in itself. So as M2 is replicating from M1, it's disseminating the updates to the group. So S2 is also a slave in the group. So you can start migrating reads to the group. And basically, you also migrate another slave, and then you have this point here, where basically when you see that the group catch up to M1, you cut the writes to M1, you wait for those writes to be replicated to M2, and then you just migrate the writes to M2. And now you have an extra server that you can also add to the group, and it's there. So now you have a group, and you can still use it in master-slave mode, right? If you use the primary configuration with secondaries, or you can have a multi-master group if you want. Another use case, a stranger use case, but still interesting, is I have different applications in different servers. Maybe maybe it's different shards and I want to aggregate the data. Or maybe it's several applications that I want to make a chain, but I don't want to spend that many servers on it, so I will just add these two applications to the same group, or something like that. So how do I do this? Basically, you start replicating from M1 into M2, and your application is still running, right? M2 will have to deal with update from M1 also with its old load, right? So maybe that's a factor of decision between M1 and M2. And basically, you start a group on M2. We add a new server here that maybe people don't want to, but for two reasons. First, quorum. So a group of two is always dangerous because of split brains, but also because there is a point in time where you will have to cut the writes to M1. And at that point in time, if you have application write to M1 and application writing to M2, at that point in time, if you have only one server, then one server would have to serve two applications. So maybe you don't want that. So I add M3 to the group as well. M3 will touch to M2, and now you migrate the writes to the group. So M2 is supposed to have all the information from M1. So you take the writes from M1 and you put it on M2, and then you you can also write to M3, write and read, of course. And then you join back M1. Maybe you want to do some provisioning of the data, because M2 has all the data that M1 has, but M1 is lacking all the data of M2, right? So maybe you want to do some provisioning first from M1, and basically you add it back to the group, and now you have either several applications in a group with automatic failover, or you have now two shards that are now one, and you can also do this in another way. You can leverage the multi-source replication and just add do aggregation with a slave, start a group on the slave, add M2 to that group, and then do the same thing. So basically when S and M2 catch up to the load on M1, so S and M2 also have the data from M1, you can migrate the writes from M1 to the group. And now you also have a group with 3 members with all the data from M1 and M2. So maybe you tried replication and it was not for you, and you want to migrate back. This is a simple scenario, but still one that we must include. So basically, you have a group, maybe it's primary master or multi-master, it doesn't matter. What you have to do is just you stop group replication in one member, you configure it to be a slave of M1, so you still get the write from M1. You go to member 2 with stop group replication, you make it a slave of M1, and now you have master slave, right? And basically, You read to the slaves, you write to the master, business as usual. And I guess I finished earlier, but that's it. We built group application based on many of the technologies that we already have. So yes, we have group communication, but for example, recovery on group application is based on master-slave. It's basically a channel that is created on group application to the master-slave. So you can join many of these things. You can do whatever you want. You can have slaves into groups, groups into slaves, multi-source, well, whatever. Semi-sync is, well, we don't know how semi-sync will comes into this picture, but you can try it or not. I don't know if we advise that. Maybe we don't advise that, but maybe we'll try that in the future. So basically, we are GA, so you can download our packages from the website. Documentation is also there. Maybe we are improving it. And there is our blogs on mysqliavailability.com with all the new stuff that we are developing. So we have a long path to go. So here is my dolphin that Fred all loves. And I'm on Twitter. I don't tweet that much, but you can reach me there. I will respond to you, I guess. And thank you. If you have any questions.
Setup, can you do it without any?
Yes, I believe so. What setup? For example, master slave to multi-master. Why do you have to? Oh yeah, not migrations. Yeah. Yes, because you never mess with the master, right? Yes, there can be some seconds of downtime here. So, but yeah, that's seconds. So yes, you have to be careful here. Basically, here you have to wait for a moment where your group is really close to the master. When the group is really close to the master, then you have seconds of downtime, maybe. Yeah. Okay. Yeah. Yeah. Yes, because the member did not fail. The member choose to leave. When the members choose to leave, there is no split branch scenario because the group knows that he left. Yes. Yes. Not much. Vitor was talking about that earlier. So if you have a group, maybe you have two members in one data center and another member in the other. These two guys can, when you write to these guys have the quorum, so they don't need to wait to this guy. But eventually the group has to, you can only send that much messages until it tests to catch up with this guy here. This guy here eventually will be a source of contention. So that's the thing we have to improve in the future.
One of the three is left because the network was down.
Yeah.
And will it then serve queries or will it just say, no, I'm not available?
It will say I'm not available. we are improving that. Yeah, Kenny has a problem, has some issues with that, because nowadays we block, basically. So, oh, sorry. Like instead of having two pairs, you have this guy also connects to another and another, and this guy. Yes, yeah, only one way. Yes, you can connect all the masters to all the masters basically with master slave. You can do that because then the GTID's mechanism will skip all redundancy. Yeah, you can do it. You can connect to more than one master. Yes?
When you have this master, multi-master, you have additional slave. Can the slave master, can that be central? Or does it have to be other? Yes.
I don't know. I will let Mark test that. Yes. Yes. No, I think are different groups. These are different groups. Each one has. That's all? Okay.